Implicit differentiation is just as it sounds like. So we are usually, up till now, we said that, well, y is equal to tangent x, and we would take the derivative of this, and y is equal to, y prime is equal to secant squared x. Something like that, where y is explicitly given to us, and we know exactly what y is, and we would take the derivative and we go from there. Okay? In implicit differentiation, we are now going to deal with situations where the function that is given is in an implicit form, whereas we don't have a direct y is equal to something. Okay? So the ones, let's look at example number one. Let's go straight into example number one. In example number one, we have y squared is equal to x, and we want to find y prime here, or dy dx. Okay, the problem is that I don't have y as something, okay? So you're not going to solve and say y is equal to plus or minus root x here, because that would give us two different functions, okay? So what we're going to do is we're going to go ahead and do the differentiation. We're going to differentiate this side with respect to x. We're going to differentiate this side with respect to x. So when we take this guy, we do the differentiation of this with respect to x. We're going to use the power rule, and we're going to say this is 2y. And then we're going to invoke the chain rule and say, well, I have to take the derivative of this guy. So it's going to be y prime. And over here on the other side, we're going to have, if I take the derivative of this with respect to x, this becomes 1. Okay? So now I can say that y prime is equal to 1 over 2y. Okay? So you'll notice that when you do the implicit differentiation, when you take the derivative of y, when you're finding dy dx, you're going to often have the y back in the expression itself. Okay? So that's how you would go about doing an implicit differentiation. So it's basically you're utilizing the chain rule. You're taking the chain rule here. You can see this is 2y. Now I take the derivative of what's in here again, so I have to take the y prime. So you're basically, it's almost like an offshoot of the chain rule. Okay? So let's see if we can do that one more time. Let's see if we can do example number 2. In example number 2, we have a circle. So I have example number 2, x squared plus y squared is equal to 25, and I want to find the slope at 3 and negative 4. Okay, so if I do that, I'm going to take the derivative of this again. We're going to take the derivative of this side with respect to x. So I'll have 2x here, and there's no need to do the chain rule here because it was just x. Now over here, I'm going to go 2y, just like we did before. It's going to be y prime with the chain rule. And over here, when I take the derivative of 25, I get 0, right? So y prime is going to be equal to negative 2x over 2y. If I solve for y prime here, move the 2x over, get negative 2x. Divide both sides by 2y, so I end up with negative x over y. So the slope, okay, the slope here at 3 and negative 4 is going to be negative 3 over negative 4, which is basically 3 over 4. Okay, so you see how I did that? Okay, so that's how you would do it. Okay. And so you can ask, so I can ask, this is the slope. No, since you've got the point now, I can ask for the tangent line here, right? Because it will be the slope here with the point going in here. So you have the point slope equation there, right? Okay. Let's move on to example number 3. Okay, so example number 3 is, show that the slope dy dx is defined at every point in the graph of that. So I have 2y is equal to x squared plus sine y. So I think to take the derivative of here, I'm going to get what? 2y prime, right? Over here I get 2x. Over here I get cosine y, but I have to do this chain rule and use the y prime here also, because I have to take the derivative of what's inside here. Okay, so over here I'm going to go ahead and I'll move it over. I get 2 minus cosine y prime is equal to 2x. So y prime is going to be equal to 2x over 2 minus cosine y. Okay, so the question was, show that the slope is defined at every point. So over here, this function is defined at everything except for when this is equal to 0, correct? Except for when the denominator is equal to 0. So when the denominator is equal to 0, you get 2 minus cosine y is equal to 0. In other words, cosine y is equal to 2. And when does this happen? When does cosine y become 2?
Never.
Never, right? Because cosine always takes a point between 1 and -1. And therefore, this is never going to be 0. Since the denominator is never going to be 0, this has a value at all points. Okay? So that's good. Let's flip the page, go to 166. There's a little green box there. Go ahead and read that for me. See if that makes sense to you. We have differentiate both sides. So how you differentiate both sides of the equation with respect to x. Collect the terms with dy dx on one side of the equation. Factor that out and then solve for it. That's what we've been doing, right? Okay, so let's do one more here. Okay, so we have example number 4. Example number 4, we have find the tangent and normal line to the ellipse x squared minus xy plus y squared is equal to 7 at the point -1 and 2. Okay, so we have to find dy dx first, right? We have to find the slope. Let's go and take the derivative of the left-hand side. I get 2x. Over here, now I have the product rule, right? So I'm going to take the derivative of this guy first, which is 1, and then I'm going to have y plus x. Then I'm going to take the derivative of y, which is y prime, plus 2y, y prime, the chain rule. And I take the derivative of 7, that's equal to 0, right? So let's go ahead and collect the terms. So I get 2x minus y minus xy prime plus 2y y prime is equal to 0. So if I collect the y primes together, I get 2y minus x y prime, not y squared, but y prime. Right? Now I'm going to have this guy, I'm going to move that over here. So it's going to be y minus 2x. So I'm going to end up with y prime is equal to y minus 2x, 2y minus x. Okay, if I divide both sides over that. So if I evaluate that when x equal to -1 and y is equal to 2, I'm going to get what? It's going to be 2 minus 2 times minus 1 over 2 times 2 minus minus 1. So for you on the top, I'm going to get 2 plus 2, which is 4. On the bottom, I'm going to get 5. So that's my slope. So since that's my slope, the tangent line is nothing more than the tangent line is going to be y minus 2, 4 5x plus 1, because it goes to this point. Then the normal line is going to be the same point, y minus 2, x plus 1, but it's going to be the opposite reciprocal of this. So it's negative 5 over 4. Okay? So let's go ahead and stop right there, and then we will continue with the derivatives higher order and a couple other things. All right? We'll do that when we come back. Are there any questions?